Hi, welcome to Data Structures and Algorithms series by Coding Allies. Coding Allies is a non-profit organization where we believe women and gender minorities should have a safe space and support system where they can foster their skills and careers in tech. I'm your host Sue. Today, we are solving this Leetcode problem 121, best time to buy and sell stock. This is the agenda. First, I will go through the problem statement and then thought process behind. In this video, out of these three listed approach, brute force, sliding window, and greedy technique, I'm going to go through the first one, brute force approach. So this is the problem. You are given an array prices where prices I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell the stock. Return the maximum profit you can achieve from this transaction. If you can't achieve any profit, return 0. Let's have a look at example. Input the prices. We've got this array price 715364. The output is 5. So let's understand this. The explanation given is we buy on day 2. In array, of course, it always start with 0, 1, 2, 3, or 0, 1, 2, 3. It always start with index 0, but in here we are saying like day 1, day 2. So in day 2, we've got this lowest priced, and then we have to sell this stock in the future, in a different day in the future. So in here, you can see the highest price is on this day, and the price is 6. So we've got this profit 5. And I suggest you draw a graph. If you draw a graph, you can see that clearer, because from here you can see we buy on day 1, we buy on this day and we sell on this day. We could do that, but the profit will be only 5 minus 1, so it will be 4. We can also do that in here. 6 minus 3, the profit will be 3. But if we compare 6 minus 1, the profit is 5, so it is a max profit. So we have to get that. We have to make sure we in the algorithm that we are going to implement, we have to make sure we keep that in mind. So let's have a look at example 2. In this example, we are given the prices. The prices are in a descending order, so 75431. So from here you can clearly see that from the graph, we buy on whichever day we buy, the price are decreasing. It's not increasing at all, so we are not going to make any profit. And another example could be the price in here given is decreasing. Another array could be all the prices are in increasing order. In that case, the first element indexed, the value will be the lowest. Here will be the highest. So we have to subtract highest minus lowest, and then we will get the maximum profit. So let's have a look at the constraint. The constraint given is price length is between 1 and 10 to the power 5. So from here you can see the edge case. If the price's length is equal to 0, then we can't buy and sell because it is only one price in the array given. So we can just simply return 0. Prices I, the value is between inclusive 0 and 10 to the power 4. Okay, let's have a look now. Let's go through the thought process. So I have gone through this already, but I just want to show you graphically again. So in here we can make the profit, which is 4. The orange one, the profit is 4. The blue one is 3. The maximum profit that we can make for this given array prices is 5. So we have to make sure we find the lowest we find the lowest price, and then we have to sell it in the future day with the we have to sell it in the future day so that we maximize our profit. So in this video, since we are going to go through the brute force approach, I'm going to use the 2 nested for loop. So this pink one is for the I. So this is the outer loop. This orange one, it is for the inner loop. So I is starting at index 0, j is starting as I plus 1 in that position. So from here, we are calculating that what we are doing is calculating the profit at every single day. We buy on day 1, we try to sell it on day 2, day 3, day 4, day 5, day 6, and then we will find out what is the maximum profit. So from here, after the first iteration, the maximum profit is minus 1, which is less than 0. So by the end of this first iteration, maximum profit will still be 0 because it is less than 0. So let's look at the second iteration. In the second iteration, I will be incremented by 1, j will be incremented by I plus 1. So j will start here. So from here, we are calculating the current profit again. So the current profit, if we buy on day 2, sell it on day 3 is 4, 5, 6, and then we will get all of these profit. And then while we are iterating, we will update the maximum profit. So from example 1, we have already seen that 5 is the maximum profit for this given array. So I'm not going to go through until the end of this array. So you can see that if we move this pink pointer to the next one in here, day 3, j pointer will be moving to here, and then we will go through the same thing again until we get to the end of this array. So let's sum up. First, in this brute force approach, we first need to initialize the maximum profit and iterate through this given array price in a nested loop. While we are iterating, we are going to calculate the current profit. And then while we are doing that, we will update the max profit if the current profit is greater than max profit. That way we will keep track of the maximum profit. So let's have a look at the code. First, this is the first step. We will initialize the max profit. It's initialized at 0. Second step, we are iterating through this prices array, and we are doing that in a nested for loop. So we've got I for the outer loop, j for the inner loop, I for this the price. So, and in this loop, we are calculating the current profit. So prices is j minus prices is I, we will get the current profit. And then we are going to compare the current profit with the max profit in the next step. In this step, we have to compare these two, and then we have to choose the maximum larger value. And then at the end of these two nested for loop, then we will return it. Then we will return the value max profit, and that will be the end of this algorithm. So let's discuss time and space complexity. Time complexity, as you can see here, I will go back. For every I, and we are going to go through j, we are iterating through, and then we will keep going. So we will be iterating through this array 2 times. So because of that, our time complexity is O of n squared. Space, this is the only variable that we have used in this algorithm. So space complexity is O of 1. If you submit this algorithm brute force approach, you will find that you will have a TLE, and it passed only 204 out of 211. And in the exceeded input, you will find that it is, I think, more than 68K. So why is that? What is TLE? So TLE, time limit exceeded, or TLE, means that the program, the algorithm that we have just written, failed to finish executing before the established time limit for the problem. So obviously our time complexity is O of n squared. So this O of n squared runtime exceeds the execution time permitted by the server. So this is the explanation from the Leetcode website itself. And so it could be, TLE could be one of the following reasons, but in our case, we know that our algorithm, we don't have any infinite loop. The data structure that we return, it's not invalid. That's not true either. So we know that our algorithm is slow, and we have a high time complexity. So let's look at the time complexity chart. So we know the output, and then this is the CPU operation, the time taken. So our algorithm currently, the time complexity is the green orange one, O of n squared. So we know that we have to bring our runtime, we have to optimize this algorithm and bring the runtime down to either O of n log n or O of n. So in summary, there are two key things that we've learned from this video. First is we learned about the brute force. So in this brute force approach, there are 3 steps. First, we initialize the max profit, and then we iterate through the array in a nested for loop, and then we calculate the current profit. And in step 3, we update the max profit if the current profit is greater than max profit. And we also learned the terminology time limit exceeded TLE and some of the reason behind, and the reason behind for our algorithm. Yeah. So in another 2 video, I'm going to go through 2 approach that will optimize our time complexity. They are greedy technique and sliding window approach. So I will put the link in the description. Thanks for watching. So thank you. Please make sure to subscribe and press the like button if you find this video helpful, and join our weekly Wednesday data structure and algorithm night where we organize peer-to-peer coding interview. You can find the event details in our Facebook page. Thank you.